Hello, this is question number 4 from the Unit 3 Higher AQA practice set 1. And this question, I think, is really quite tricky. I'm going to need a bit of space, so I'm just going to move that up. So we have 5 roads or footpaths meeting at a particular point, as in the diagram. And what we have to do for the first part of the question is we have to talk about, sorry, that's not the first part. That's the first part. To talk about Kate, who is at O, the origin, and walking towards B. On what bearing does she walk? That word bearing means that we need to give a 3-figure bearing. In other words, we need to give an angle measured from north, and we need to do it using 3 digits. So some examples of 3-figure bearings would be 245 degrees, 180 degrees, or if you've got a number lower than 100, you might write something like that, 060 degrees. It needs to be 3 figures. So if we have a look at this angle here, and in particular the straight line running from north to south, you can tell that the angle is going to be 180, take away 80, take away 60. What I'm saying there is it's the 180 degrees on a straight line. If I take away the 60 and the 80, I will find out what's left, what this angle of turn would have to be. And doing that gives you 40 degrees. And so we write our answer as 040. The degrees are already given in the question. I'm going to mark that on the diagram just for the next part. So the next part of this question says Ben is at B and walks to meet Kate. So Ben is working from here back towards Kate in the centre. On what bearing does he walk? Now what you need to do is put yourself a little north in there by B and continue it down to south. And we need to look at this bearing that goes all the way around from north in a clockwise direction. Bearings are always measured from north in a clockwise direction. So Ben is walking in this direction towards the centre, but towards the origin. This angle is what we're after. Now the first half of this is just 180. Shouldn't say half. First part of this turn is 180, and then this bit in here is 40 degrees. The reason that it's 40 degrees is because it's alternate with this 40 degrees here. If you look, you can see there are 2 parallel lines. Both the north lines are parallel. So we have what some people are used to calling a Z angle. 40 in there and 40 in there. So you can see the total bearing here is 180 plus 40, which gives a final bearing of 220 degrees. Okay, the last part of this question is the really tricky bit. It says, Frank is walking from A to O. When he gets to O, what angle clockwise does he need to turn through to continue to C? So Frank is walking from A to O, and when he reaches O, he'll be facing in this direction. Now, that direction, then he needs to turn clockwise all the way around to get back to face towards C. So really, what I'm interested in is this angle in here. and taking it away from 360 will give me the correct angle, angle clockwise. So what is this angle in here? Well, we've got 40 and 80 and this little bit here and this angle here, and they should all make a straight line, because we said when Frank is walking from A to O, if he were to carry straight on, that would be this line here. So those angles all need to add up to 180. At the moment we've got 80 and 40. This angle in here, you can tell what that is, because what we've got here is 50 degrees. That makes a right angle there and a right angle in there. Once you've worked out that that's 90 and 80, this one has got to be 10 degrees. So the total distance, or the total angle, that Frank must turn from this position, facing down that way, all the way around, whoops, like that, to face towards C, is going to be 360, it's nearly a full circle, minus that 10 degrees. So 350 degrees. Okay, if you're not sure why some of those angles are what they are, you may need to do a little bit more work just to prove to yourself that this is a straight line and therefore that angle has to be 50. You can do that quite easily. These three angles on the other side of that straight line do add up to 180.